Welcome back to my YouTube channel, and we have been going through a series of gas turbine engine tutorials, starting from the air intake section, compressor section, turbine section, combustion section, exhaust section. Now we are onto this gas turbine engine classification. And what are your expectations by the end of this presentation? You will have known what's a gas, what's a turboprop, what is a turbojet, what's a turboshaft. You will have known the two types of gas turbine engine classification, and a lot of good stuff about the gas turbine engine classification. And it is still Professor Kafaras taking you on from the Afritech University of Aeronautical Sciences. It's a virtual university. Duration, we are going to take 20 minutes for the lecture, because I don't want it to be a burden to you. It just has to be simple. Okay, back to the point. With our introduction, we see that we have different types of gas turbine engine, and they exist according to their tasks. So how do we make a difference? It's because of the design characteristics. So the design characteristics, we have the number of spools, we have the principle of compression that is employed there in the gas turbine. Then we have the distribution of airflow within the engine. It also brings about the design characteristics. Then we have the utilization of the exhaust gas. That is a design characteristic used to differentiate. So we have two types of gas turbine engines. We have the thrust producing and the torque producing. So the thrust producing engines are turbojet, turbofan, ramjet, and pulsejet. TTRP, that is like an abbreviation or an acronym, TTRP. You know, we have turbojet, JFRP, jet, fan, ram, pulse. And you go to, so briefly we can see how a turbojet is. We have our intake here, we have the compressor section, we have the combustion section, then we have the turbine, the turbine turning the compressor. Then we see the high-speed exhaust gases. The exhaust gases are exhausted as a high-speed exhaust gas. We see the turbofan. It has a fan. So in other words here, the exhaust gets out of the engine as a jet, a solid jet of high-speed gases. We see the turbofan. This is the fan. Before you reach the compressor section, then we have the bypass air. Then we have the hot exhaust stream. So the exhaust gets out as a stream of hot gases. So you can see the main difference. We have the fan here. Here we don't have the fan. So we go to, this is the what? Oh, Jesus Christ. So this is briefly how a gas turbine engine looks like. This is the ramjet. Then we have we saw something like a pulsejet. So this is called a pulsejet, the last one. So here we see the ramjet. Fuel nozzles are here, combustion chamber, venturi, then jet nozzle. The pulsejet, we have the air inlet, 3 shutter valves open, then combustion chamber, then jet nozzle. So it is in form of a pulse. Keep opening, closing, opening, closing. That's a parts jet. So we look at this comparison of thrust producing and then torque producing. We see this example. Acceleration, thrust producing, we have something. Oh, Jesus Christ. We have acceleration of large mass through small increase in velocity. That's why we see like a turboprop. We saw that the turboprop is a torque producing engine. It is not a thrust producing, it is a torque producing. So torque producing engines, what they have mostly is acceleration of large mass through small increase in velocity. Small mass accelerated through a small increase in velocity. We have that torque producing thrust, the example of the turbojets. Acceleration of a small mass through large increase in velocity. You're having a small mass, but you accelerate to increase its speed by a large percentage. That's a turbojet. Thrust, that's a thrust, a thrust producing engine. Torque producing ones, you have a large mass, then you just increase through a small velocity, small increase in velocity. So we move on. Turbojet engine. So what's a turbojet? A turbojet, we have reached on the core part of our a turbojet is made up of the following components. We have a multi-stage compressor, we have a combustor, we have a single or multi-stage turbine. Those are the main components of a turbojet. Multi-stage compressor that means a series of stator and rotor. Then we have a combustor, and you have a single or multi-stage turbine. Basic components of a turbojet engine. So we saw behind there, we saw that we have a multi-stage compressor, combustor, single or multi-stage turbine. Now we look at this example is a centrifugal. It includes a centrifugal compressor. That's why we have a diffuser. So we have air inlet, duet, have the compressor, multi-stage compressor, series of these. Here we go the diffuser. Combustors are here. Then we see the turbine. It is also single or multi-stage, but this is multi-stage. Then we have the tailpipe and the jet nozzle, turbojet. So the propulsive force in a turbojet is provided by the reaction of the reaction force is generated by exhaust gas. Let's look at the operation. Turbojet engine operation. Air enters the inlet and its pressure is increased by the compressor. Fuel is added in the combustor, and the expansion created by the heat forces the turbine wheel to rotate. The turbine section is coupled to the compressor section and directly drives it. Air enters the inlet and its pressure is increased by the compressor while reducing its velocity. Then fuel is added in the combustor and expansion created by the heat forces the turbine wheel to rotate. Turbine section is coupled to the compressor section and directly drives it. The energy remaining downstream of the turbine in the tailpipe accelerates into the atmosphere and creates the reaction we refer to as thrust. They are less efficient due to losses from noise and incomplete combustion. Turbojet are less efficient unless if they have solved this issue. Most aircrafts, the newer ones, they have tried to solve noise and incomplete combustion. So we have the engine pressure ratio, EPR. An engine's EPR is the ratio of turbine discharge pressure to the engine inlet pressure. Ratio of turbine discharge pressure, TDP, to the engine inlet air pressure, EIAP. Engine inlet air pressure. EPR gauge readings are an indication of the amount of thrust being produced for a given power lever setting. EPR gauge readings indicate the amount of thrust being produced for a given power lever setting. Total pressure pickups or EPR probes. They measure the air pressure at 2 points in the engine. So EPR probes, if you want to make that ratio of the TDP, turbine discharge pressure, to the engine inlet air pressure, we have 2 points, and one EPR probe is located at the compressor inlet, and the second EPR probe is located just aft of the last stage turbine in the exhaust section. Last stage turbine in the exhaust section. That's the last probe. The first one, compressor inlet. The second one, aft of the last stage turbine in the exhaust section. EPR readings are often used as verification of power settings for takeoff, climb, and cruise. So EPR readings are affected by and are dependent on pressure, altitude, and outside air temperature. Now we move on to the turbofan engine. They are classified according to the portion of mass airflow that is bypassed around the engine. They are denoted as high pass and low bypass. High bypass and low bypass. Classify the proportion of mass airflow that is passed around the engine, because it has a fan that keeps passing the air around the engine. The amount of air that is passed in relation to the air that passes through the engine is termed as bypass ratio. So this fan blows air into the engine. There's air that passes in the normal engine, then there is air that goes to the bypass area. So that is called a bypass ratio, when we get the air that is bypassed in relation to air that passes through the engine. Components. Similar to turbojet engine, additionally it has no fan. It has a fan and a low pressure compressor of large diameter. So you can look at the low bypass. Low bypass, that means the amount of air that bypasses the main air intake that doesn't go through the main direction of air is less. So we can see its parts. This is a fan, this is a low pressure compressor, this is the high pressure compressor, then this is the high pressure turbine, this is the low pressure turbine. Okay, the ram bypass duct. So this is the fan bypass duct, then this is the exhaust. If we look at the high bypass ratio, we see the fan, we see the fan discharge duct, we see the low pressure compressor, we see the high pressure compressor, fan high pressure turbine, then low pressure turbine. Then we see the cone engine exhaust. So we can see this is where our bypass is, and we have a high bypass. Actually, there is a lot of air that goes through the bypass as compared to the air that goes through the normal path for the air. So we can see now in full clear diagram, air inlet, we see the fan, see the low pressure compressor, high pressure compressor, combustors, two-stage high pressure turbine to turn outer shaft, low pressure turbine to turn the inner shaft, then twin spool shaft to turn the fan and the compressor. This is the shaft that turns the fan and the compressor. So this one turns the outer shaft, then the low pressure turns the inner shaft. Then we have the fan air bypassing the jet engine. That's the bypass. We move to the next turbofan. Let's briefly see it. We see the fan, the compressor, low pressure, high pressure. Then we see the turbine, high pressure, low pressure. We see that the low pressure turbine drives the inner shaft, and the high pressure drives the outer shaft. Then we have the main shaft that drives the fan and the compressors. Okay, that's briefly. We got the turbofan components, and we can see briefly here the inlet duct, the fan discharge, then the hot exhaust. You see here also inlet like this, hot exhaust gas, fan discharge. So turbofan operation, similar to turboprop, the turbine section is designed to absorb more energy from the hot gas than is necessary to drive the compressor alone. So the turbine is designed to absorb more energy from the hot gas than is necessary to drive. So the excess shaft power is used to drive a fan. Yeah, we have the energy that's absorbed to drive the compressor, and another one is used to drive the fan because we have an excess fan. That's, I think, we see that shaft is the twin spool shaft that turns the fan and the compressors. Then we go to part of the air entering the engine intake bypasses the inner or core engine and expands in a separate nozzle, provide a cold thrust. Some types mix the cold flow with the hot exhaust gas in the core engine to increase propulsive efficiency. So here we see part of the engine intake bypasses the inner or core engine and expands in a separate nozzle to provide a cold thrust. So some types mix the cold flow with the exhaust gas in the core engine to increase the propulsive efficiency. Now we move to the turboprop. That's a torque producing engine. Turboprop components, basic layout. We have a propeller, then we have a planetary reduction gears, then we have free turbine. These are free turbine turboprop. It differs mainly by an additional turbine to drive the propeller, a two-spool arrangement of the rotational machinery. Then we have a mechanical reduction gear to reduce the high turbine speed to a moderate speed of the propeller. Turboprop operation. The process of combustion in the combustor is similar to that of a turbojet. Turbine section of gas generator is designed so that more energy is abstracted from the hot gas than is necessary to drive the compressor and some auxiliaries. Here, the excess shaft power is used to drive a propeller. So we saw that for the turbo shaft, it is used turbofan. The excess shaft power is used to drive a fan. But here in turboprop, it is used to drive a propeller. So turboprop accelerates a high mass flow to a low velocity. Turboprop are very efficient at low air speeds. Two main types of turboprop engines. We have a fixed shaft, also called a gear coupled turbine, and we have the free turbine. Fixed turbine. The fixed turbine is connected directly to the compressor, reduction gearbox, and a propeller shaft. Here we have the turbine connected to the compressor, reduction gear, and the propeller shaft. So this is briefly what we can see. We see the reduction gears, power output shaft, integral inlet duct, two-stage centrifugal compressor, three-stage axial turbine, so we see that the turbine is directly connected to the compressor and the propeller and the reduction gears. Free turbine, also called a gas coupled. We have the turbine is not connected to the propeller, is not connected to the reduction gear and to the compressor. And we see the turboshaft engine. Turboshaft, it is similar to turboprop. They differ primarily in the task of the second turbine. Instead of driving a propeller, the turbine-driven shaft is connected to a transmission system which drives helicopter rotor blades. Components. The engine also has 5 major components: the inlet section, compressor section, and combustor section, turbine section, and the exhaust. Operation. The compressor raises the pressure of the incoming air. This is guided into the combustion chamber, mixed with vaporized fuel and burned. The hot gas expands through 2 separate turbines. The first of these drives the compressor. The second delivers shaft horsepower to drive the helicopter rotor via a transmission gearbox. The gas is finally released through an exhaust duct without producing any thrust. So that's the end of our presentation. We have looked at the different types of gas turbine engines, and we let's do a recap. Looked at a turbo shaft that here the second turbine is used to drive a propeller, drive a helicopter rotor blades via a transmission system. That's a turbo shaft. Now we see the turboprop, that the excess shaft power is used to drive a propeller via reduction gears. That's the main difference. We have reduction gears, and then it drives a propeller. Then we have the turbofan, whereby the excess shaft power is used to drive a fan. We have the turbojet, which is mainly not having any other, but has a multi-stage compressor and a combustor. So it is the basic gas turbine engine, the turbojet. Though it is less efficient due to losses from noise and incomplete combustion. With those few words, I think we have better understood thrust producing, where we accelerate a small mass of air via a high velocity, and torque producing, we accelerate a large mass through a small increase in velocity. Thank you for listening. Catch up with you next time. Have the best of the day.